Hello everyone, this is the crash course in mole calculations. All right, let's do a couple examples together. First, what is the molar mass of SO2? SO2. Now, that's a matter of looking at the periodic table. All right, we got to find sulfur on the periodic table. That's right here. And oxygen is right above it. All right, now, for this, I have in the formula one S and two O's. One S and two O's. So I'm going to do 1 times the molar mass of sulfur, 32.07. 32.07. Plus 2 times the molar mass of oxygen, which is 16.00. 16.00. All right. Now, I'm going to punch that into the calculator. I got 1 times 32.07 plus 2 times 16 equals 64.07. 64.07. That's the molar mass. That is grams per mole. Grams per mole for the compound SO2. All right, in the test it says show your work, make it look just like that. All right, now, question A. What's the mass in grams of 435 moles of SO2? Okay, let's take a look at this chart. What does this chart tell us? It's got some conversion factors in the box at the top, and it's got a little diagram showing us the different types of conversions that we might do. All right, we could convert from molecules or atoms into moles. We can convert from moles into liters. We can convert moles into grams. And then we can go the other way. We can go from moles into molecules, liters into moles, grams into moles. We could go in either direction on each one of these things. Each one of these double arrows here indicate a step in the process. All right? And we can go either direction, depends on the problem. All right, we need a conversion factor for each one of those steps. If I'm going either direction on this one, I use this conversion factor right here. 1 mole is equal to 22.4 liters. If I'm going from moles to molecules or molecules to moles, I'm going to use this conversion factor right here. If I'm going from grams to moles or moles to grams, then I use this conversion factor. That's a molar mass from the periodic table. We just calculated one up above. All right, now, whether we put this thing right side up or upside down depends on which direction we're going to go. So we got to first decide how that's going to look. Now, let's look at each one of these problems. In every case, we are going to have something that we are given. Moles of SO2, liters of this gas, grams of this. So whatever is given with a number, that's your starting point. All right, so we set it up 435 moles. All right, kind of important to write that stuff down. All right, looking at the second one, 59.48 liters, 15.7 grams. All right, so those are our givens, our starting point. Now, in each one of these, we're going to have another conversion factor come next. No matter what, in every case, whatever it is you're starting with has to be on the bottom of the next thing. Moles there. All right, the second one, liters up, liters down. The third one, grams up, grams down. All right, that's how this is going to go. Now we got to fill in the rest of the stuff. All right, looking at the chart. All right, looking at the chart. In letter A here, I'm starting with moles and I want to go to grams. I'm starting with moles, I want to go to grams. So the conversion factor I got to use is this thing here, the grams per mole, grams per mole. Therefore, on the top, I got to have grams, and the bottom, I got to have moles. Now, grams per mole, that's a molar mass. 1 mole is, in this case, 64.07. All right? So this is a one-step problem. We're going from moles to grams. All right? From one oval to another oval. All right? We are set, then, to punch this in to the calculator. 435 times 64 0.07 equals, that's my dog barking. The calculator says 27870.45. Now I have to decide where I'm going to round it. Okay, now where am I going to round it? Let's see. 435 has 3 digits. 6407 has 4 digits. So I have to round the answer to 3 digits. 1, 2, 3. So I'm going to round it 2, 7, and 8 will become a 9. And then I got to put a couple zeros to get that decimal in the right place. Call it grams. All right, there we are. All right, question B. All right, I'm starting with liters. I want to find moles. On the chart over here, I'm starting with liters. I want to have moles. I need one step. And if I'm going to end with moles, that's going to go on the top. What do I put in the blanks? This is where the 22.4 comes in. 22.40 liters, 1 mole. 1 mole. All right, I'm set to punch into the calculator. 59.48 times 1 divided by 22.40 equals, calculator says 2.65537, etc. How many digits should I round it to? 59.48 has 4. 22.40 has 4. I gotta have 4. 1, 2, 3, 4. I'm gonna round it to 2.655. Call it moles. Question C. I'm starting with 15.7 grams, and I want to convert that into molecules. Looking on this little chart, I'm going to have to go from grams to moles, and then from moles to molecules. I'm going to have 2 steps in this problem. So I'm going to have another parentheses to go right in there. All right. For the first step, to convert from grams to moles, I'm going to have moles on the top right here. And that's going to be a conversion factor of the molar mass. That gives me the 64.07 grams for 1 mole. Now, if I ended now, I would end up in moles. I want to end up in molecules. So the next step is going to have moles on the bottom and molecules on the top. That would be 1 mole and 6.022 times 10 to the 23rd molecules. All right, we're set for the calculator. That would be 15.7 times 1 times 6.022 times 10 to the 23rd. Divided by 64.07 divided by 1 equals, calculator says 1.475657 times 10 to the 23rd. Where should I round it? Let's see, the 15.7 is 3 digits. 64.7 has 4 digits. 6.02 has 4 digits. I got to round it to 3 digits, the smallest one. 1, 2, 3. That's going to give me 1.48 times 10 to the 23rd molecules. All right, there's some samples. Now, some of the problems might be 1 step, having 2 parentheses. Some might be 2 steps, having 3 parentheses. Just figure out where you're starting, where you're ending and what conversion factors you got to use. If you're doing anything with volume or liters, you're going to use 22.4. If you're doing anything with molecules, you're going to use 6.02 times 10 to the 23rd. If you're doing anything from grams and moles, you're going to use the molar mass from the periodic table. That depends on what compound you're talking about.